Okay. So, after taking off that, we can see that the PLA definitely could not handle the torque on that servo motor. Servo's doing just fine. It could definitely handle the weight based off just from it being connected to the gear. Okay, yeah, so 3 slice parts fit onto this little gap right here. All right, so we got the ASA printing, very durable, UV resistant material, which is what we need. We've got 2 different sets for the 2 different sides. We'll check back in later. So here is the model that we're going to be dealing with today. Basically, this is going to be one full object. These 2 are going to be glued together, and this is going to be connected to the servo motor. This is where it's going to slot in. Generic ASA for this. Initial layer is going to be 30 millimeters. Outer wall is going to be 60. Use gyroid and an 80 sparse infill density. So yeah, I like to go around like 10 to 15 degrees increase from the default setting that it already has on Bamboo. So it was originally 250, went up to 260, tried 270. That was a little too hot. Okay, so here they are. This is how they turned out. I epoxied both printed parts together, and same as this one. Now this part fits into the side of the LED bar, and then this side I will attach the included servo motor attachments that came with the MG995. In these holes, I'll be able to screw through this and make a solid connection on 4 different sides. It's still too small. Awesome. Now this go onto each of these holes, and on the other side we'll have these little thread nuts, and we can actually fasten that into place. So I'm gonna go ahead and take out one of these Allen wrenches, screw it in, and I'm gonna use 2 screws, one over here, one over there, because I only have 4 of these. Oh, not good practice, but whatever. Oh no, we're good. We're way good. Oh yeah, look at that. Yeah, this is not gonna need 4 screws. This is sturdy enough. Anyways, let's find the second hole. Let's just do right there. Don't want to break anything. You just want enough space so you can get that thread adapter through. All right, all done. Now what I'm gonna be using to control the servo motors is just gonna be a remote relay. It's got a remote control with it. So it's a 1-channel receiver. It's got normally open terminal and a normally closed, as well as a common terminal. So this relay switch is actually operating on 12 volts, and the Arduino Nano operates on 5. All right, I set up some circuitry with the Arduino, the relay switch, and the 2 servo motors. So if I turn on, get some power running through there, and I can use this, that'll be what will be hooked onto the sides of the LED. This is normally open, so that means that when this is powered on, these are going to be always facing forward. When I turn it off, they're going to be facing backwards. I got it marked so that this will be forward facing, that I know that the LED will be facing forward, and once this is rotated, it'll be facing backwards for more aerodynamics. I'll show what that means in a second. Basically, if I have the LED pointing backwards, you can see how this little triangle shape can improve for better aerodynamics, since the wind it's cutting through the air, cutting through the wind, so it'll drag a little bit easier. But if it's facing this way, it's a less aerodynamic. So the off state is going to be this, on state is going to be this. Time to put them on the sides. Here it is. It works perfectly fine. I even labeled it to know which direction it goes to and for which side it goes to, right or left. So I ran a cord all the way up there so I can get an exact measurement from powering the circuitry inside of a little black box that I'm gonna put right there. Running all the way down here will be connecting the ground, and we'll add the fuse tab to the red. Okay, so the red wire has been stripped, and now we can add that. So that now that's connected, all we need to do is to strip the negative, put it on the negative side of the frame. So here I am in AutoCAD, and what I'm doing is just making a case for the breadboard with all the electronic components, and a cover for us for some sealing and water protection. So here I'm gonna put it on to the mounting brackets. Stay like that. Other side. Okay, so I've got both of the servos on, correctly labeled, so I know which pin and which direction it's going. I've also got some of the teeth marked. Took this off to make it easier to put these on, and I'll put them on later. Circuitry is out and connected directly to the battery going down. Is this one and this one that are going way up there. Alright, so we've got the fuse tap in one of the slots that I found in the hood, not the actual driver's seat. 10 amp fuse connected to it. Use the wire connector for the positive, and this is still going to be connected to the frame of the car. And now this is not a constant fuse. This meaning that this is powered off when the vehicle's off. Turns on, it's gonna be powered on. So as of right now, this is 0 volts. Some of these other ones do read 12 volts as the car battery rating, but this is great because we're not going to be drawing power constantly from those electronics up there. We're chilling. Now we can go ahead and test it out. So it is on. Again, this is not a constant fuse, so this is ideal power management for now. So there you go. Now I'm just gonna put this plastic piece back on. All right, wires will be zip tied later. All set. Go ahead and test it out. Turn on the car. Look at that. Let's get to use it. Look at that. Boom, baby. Oh yeah, baby. Woo! Look at that thing. This is like fully modular where you can have the breadboard inside. You can add like a capacitor for smoother movement. You could add a buzzer if it's not working for some reason, if the voltage is too low. Incredible. You turn it off, it'll simply go back down. Look at that. Woo! And you can now attach it to your key. All right, so here is the core of what's going on within this LED build. This control signal on the left side is basically the Arduino. This is connected to pin 3, where the remote relay switch is triggered. That is connected to a 1K resistor, 1K ohm resistor, and that is going to the base of this TIP 120. So this is a transistor, right? It's a BJT transistor to be specific, or bipolar junction transistor. And essentially, this thing has 3 pins. It has a base, it has a collector, and it has an emitter. And all 3 of these work together to regulate voltage and current. Now, in an NPM, or negative, positive, negative. So what happens is when you click the remote, it sends a signal, and this signal has, I don't know, a couple of milliamps of current, let's say like 12 milliamps. So that goes to the base for low power, kind of just normal signals or PWMs or like a low frequency stuff. Anyways, on the collector side, this is where you want to have like the bigger load stuff. So here we have connected the 2 motors. Other sides are ground, and the power is connected to the collector. Everything is being powered by this 5-volt voltage source. Emitters in an NPN always go to ground. So it's kind of like they call it the drain. On this right side, the last thing is going to be this thing called a diode. This is the manufactured part. Since we're dealing with a bunch of different electronic components that operate at different current and voltage, we're going to need a way to regulate that and not make it where it spikes and potentially fry one of these electronic components. The thing that solves this is a diode. First of all, it only moves current into one direction, wherever this is pointing. So if this was kind of like upside down, current would be going to the emitter. So typically with an NPN, like this one here, is in a reverse bias direction. This is a reverse bias, meaning that the negative end of the diode is connected to power source. The positive is to the ground. This way, it protects the NPN from getting massive loads of current from the motors, because these motors are operating around like 0.5 amp altogether. And so when this happens, the current only is going to be able to flow in one direction. And you can protect the current coming in here and then eventually like spiking through and frying the Arduino. This was a cool build. Hopefully you guys enjoyed. I will see you in the next video. Peace.